Welcome to Math Mini Lessons. My name is Sarah, and in this video, we're going to start breaking down the 4th grade test. Specifically, we're going to look at a lot of questions from last year's exam, and then we're going to use our equation editor to break down the constructed response. But in this video, we're going to do only multiple choice. So here's the thing. There are 35 multiple choice questions on the New York State test. 30 of them are on the first day, and 5 are on the second day. So what we're going to do is I'm going to break down 35 questions from this test. You can find the link to the exam. I have it here in the description of the video, so you can find most of these questions. I did add some additional questions from other exams to make it a full test, so you can actually hit pause and try any of these problems, and I'll give you a reveal so you can see what the answer is. So with that, we're going to jump to the very first set of multiple choice questions. All right, here are the first 3, 1, 2, and 3. I'll show the answers. Check off and see what you got. If you got them right, awesome. Go to the next chapter. If not, stay and just watch how I answer these questions. So here we go. For 1 is D, for 2 is C, and for 3 is C. Check those off into your work. All right, we'll start with the first one, number 1. Carter has 9 comic books. Ben has 3 times as many as Carter. How many comic books does Ben have? So we know what Carter has. Carter has 9, and Ben has 3 times as many. So I'm doing 9 times 3, and that's how I get 27. All right, and if you want, you could also annotate, like we know this is Carter, and we know Ben has 3 times as much as Carter. So let's go to the next one. Which value makes the equation true? So I need to know what this number is. So I'm going to start by, here's 3/4. And what I want to do is I'm going to extend this until I get to 9. Why am I extending from here? Because I know that the numbers are getting bigger from 3 up. So I'm going to skip count by 3s and make equivalent fractions. So watch this. 3, 6, 9, which is the number I want. So I have the numerator I want, so now I'm going to skip count by my denominator over here. And I'm going to skip count by 4s to get the denominator. So 4, 8, and 12. And so this is my fraction 9 out of 12. So that is what this number down here must be. It must be 12. All right, so this is a really awesome strategy that we can use to create equivalent fractions. What some schools also teach is sometimes they make it called like a magic number or a property of 1, where you have to think what can you multiply by to make a product of 9. So if 3 is a factor, 3 times what will give you a product of 9? The answer will be 3. So you will end up multiplying by 3 over 3 to figure out this bottom number. Okay, and that's another way that you can get 3 times 4 is 9. So either way will work. Hey, pause. You can jot this down into your notes at any point in time. Let's look at the number 3 one. Matt has 4 pens. Sue has 4 times as many as Matt. So Matt has 4, but Sue has 4 times as many as Matt. Okay? And then actually let's kind of feel like writing it down this way. So here's Matt, here's Sue, and we're going to have Chris. So Sue has 4 times whatever Matt has, and then it says Chris has 2 times whatever Sue has. What equation can be used to determine it? So if I started with 4, this would be Matt. If I times it by 4, this will give me what Sue has. And then if I times it by 2, altogether, this will give me what Chris has. So I'm going to start with the first 2. 4 times 4 is 16. So that's what Sue has, 16. And 16 times 2 is equal to 32. The thing is, they're not asking how many does Chris actually have. They just want to know which equation. And you can kind of see it here. At first, I multiplied 4 times 4, and then I multiplied times 2, and there it is. That's how we got C. All right, so hit pause and jot this down into your notes, and we'll go to the next chapter. Let's look at the next 3, 4, 5, and 6. Get ready to check off your answers. Okay, ready? So 4 is C, 5 is C, and 6 is B. Check off and see how you did. If you're still here, we're going to start by going over 4 first. Which equation represents the statement below? 48 is 6 times as many as 8. So I say 48 is, so I make an equal sign, 6 times as many as 8. So that's what I have here, and that is equal to C. And that makes sense because they even put times in right here in the problem, and the only one that had times was C. So that one was kind of like a gimme. All right, let's go to the next one. What is the measure in degrees of an angle that represents 1/4 of a complete circle? So 1/4 of the degrees in a circle. Okay. So we know that there are 360 degrees in a circle. So they always say 360. There are 2 ways I can think about doing this. One is to just think of a circle. And if you know the whole thing is 360, you can cut it into 4 pieces. And so you could think of 360 and just divide by 4. And you would actually end up getting 90. So 90 plus 90 plus 90 plus 90 will give us 360. So that's the first way I can kind of see a kid working this out if you really didn't know how to find 1/4 of a number. Another way you can do this is if I want 1/4 of 360, this is telling me I want a part of a number, and the way I can find that part is by multiplying. So you can do 1/4 times 360, and I'm going to put a little 1 underneath it so I can multiply these fractions, and you'll get 360 over 4, which is the same thing as 360 divided by 4. And if you do that division work, even though I didn't show it a second ago, 4 can't go into 3. 4 goes into 36 9 times, and then you have to put that 0 at the end. So you get the entire 90. All right. Let's look at the next one, number 5. I am going to erase this division just to give us some space. Tatum walks her dog 2/3 mile every day after school. That's a nice thing to do. My dog would love being walked that much every single day. How many miles does she walk in 5 days? Again, 2 ways I can see you doing this. One is you can just do 2/3 and repeatedly add it 5 times. So you can do this, or you can just do 2/3 times 5. Both of them work. Both will work for this. If you did it the additional way, you know that you're not adding your denominator, so your denominator will stay 3, and you would just add your numerators, 2, 4, 6, 8, and 10. And you will get 10 over 3, which is B. Or you could multiply 2/3 times 5, put a 1 under the 5 so it turns into a fraction, improper fraction, and now when you multiply it, you also get 10 over 3. This problem didn't ask us to change this from improper to a mixed number, so we can just stay right there. But there's our answer, 10 over 3. All right, hit pause and jot this down into your notes, and we'll go to the next set of questions. All right, we got some geometry questions for 7 and 8. For 7, the answer is C, 180 minus 70. And for for 8, you get C. This one over here. So let's start with the first one. If you got it right, go to the next chapter. Not, stay right here. We'll just go over it together. So the first one, Ray has divided KM. Let me read that one more time. Ray KM divides straight angle JKL into 2 parts. Okay, so this right here gives us 2 angles now. Which equation best represents how to find the measure of angle? This one over here, which is JKM. So JKM. Obviously, we're looking for this angle because this one over here is given to us, which is angle MKL. So what do we know? We know that this is, if I were to go from here to here, this would be a straight angle. This whole thing would have been 180 degrees, right? But because we already know this part over here is 70, what's the rest? So all I would have to do is I would do 180 and I would take away the 70, and that would have given me this other piece of 110. And so that work matches this expression. So what I kind of love about a lot of these problems, notice they're not asking us for the answer. They want to know an expression that can be used to find the answer, which is super cool because they want to know about our thinking and our pathway, not just about an answer in math. In the second one, which line pair appears to be perpendicular? And as soon as you think of perpendicular, I want you to think of the word 90-degree angles. So these are two lines that when they cross together, it's kind of like when you play Call of Duty, the crosshairs, like when you're aiming and you're looking for things. So they make perfect right angles. So A, this one does intersect, but that's not a 90-degree angle. Same thing with B. It intersects, but that's not 90 degree. D, they're never going to create perpendicular lines. They're parallel. They just don't touch. But in C, you can see how they make those perfect 90-degree angles. So this one is perpendicular. All right, so this was just a vocab word. Hit pause and jot this one down into your notes. Let's look at 9 and 10. The answers for 9 is D, and for 10 is A. All right, we'll start with the first one. For number 9, we have brownies are sold at a bake sale. We have 3 pans of brownies are for sale. I get tongue-tied sometimes. And then each pan has 5 rows with 25 brownies, and each brownie is $2. I want to know how much money they made in all. So this is how I worked it out. I thought about it and I was like, well, we have 3 pans and each pan has 25 brownies because it's 5 rows of 5. So I could just multiply that. There's 3 pans with 25 brownies and each brownie is $2. So I could just multiply all of these numbers to figure out my answer. And when I do that, 3 times 25 times 2, I get 150. Okay, and that kind of makes sense. Now, if you need to do it in smaller pieces, that's okay, because I recognize sometimes that happens. So you can just think of it just piece by piece. 3 pans with 25 brownies, and that will give you 75. And then you can do 75 times 2. The second one for D, this is another vocab one. They want to know which statement about the diagram below is most likely true. I don't like that color. Hold on. Is most likely true. All right, so there's a lot of vocab here. So the first one is line AB is perpendicular to CD. Okay, so remember when we said perpendicular, that means it makes 90-degree angles. So let's see if that's true. AB is here, and here's CD. Yep, that makes a right angle. That makes 4 right angles. That's what the answer is A. But I want to just check off with the other ones and tell you why they're not true. So with the second one, we have AB is parallel. So when they're parallel, remember it's like parallel parking. They don't touch. They won't ever touch. So here's AB and here's CD. That's not true because they do intersect. So nope, not true. For C, EF is perpendicular to CD. So that's another one. So here's EF and here's CD. So these do intersect, but that's not a right angle. These are tiny angles here, bigger angles here. So no, not 90 degrees. And the last one, we have the word parallel again. So remember, we know that means they will never touch. And EF and CD, they intersect, so that cannot be it. All right, so hit pause and jot this one down to your notes. And those words should be ones that you can visually see and explain when you see them. Let's look at 11 and 12. The answer for 11 is D. And the answer for 12 is B. So check off with your work. And, oops, Siri came on for a second. We don't need her. All right, let's look at the first one if you're still here. With the first one, we want to know what fraction can be added to 4/12 to make one whole. So I want to know what number plus 4/12 is equal to 1. Well, here's the first thing I'm going to do when I'm thinking about this. I really want to make the 1 into a fraction. So what if I want it to be 12 over 12? What would I have to add? So the funny thing is that now some people can just subtract and think backwards, but what plus 4 makes 12 is what you're thinking. And the only thing that would make that true is if n is equal to 8/12, which is D. All right, with the second one on this page, number 12, it's a rounding problem. We want to know which number when rounded to the nearest thousand makes 17,000. So my rule is when we do rounding, we already know what place we're looking for, which is 1,000. So we're going to look at the buddy on the right side. So we're always going to look to the right. So here's some eyeballs. We're going to look on our right, wherever that number is on the right. And if it's 0 to 4, we're going to round down to the floor. If it's more than 5, we round up to the sky. So all I'm going to do here is I'm going to write, here are the 4 numbers for A, B, C, and D. So I'm going to look at our buddy. Here's our buddy in this place, which is a 1. And I'm going to look, the buddy right behind it is a 2. So because this buddy, all this switching around drove me crazy. We're looking at the 6, and we're going to look at the buddy behind it, which is a 1. So my buddy is a 1, so that means I'm going to round down to 16,000. Okay? So the reason that works is that I'm thinking I have a number. So like this number is 16,129. It is between, if I'm counting by thousands, 16,000 and 17,000. So I'm looking at my buddy to tell me where it is. So 16,100, that means I'm much closer to the 16,000. And that makes a lot of sense because, and I didn't draw it completely well, we know that halfway between in thousands would be 500. That's why we have that 0 to 4, we round down, and this number is on this side, 16,129. So we round down to 16,000. If it was more than 5, if this digit in the hundreds place was more than 5, it would be somewhere over here, and then we would round up. Okay, so that's kind of the thinking that I'm using here. So for B, here's the sixes and the thousands. My buddy behind it is a 9. So that means I'm going to round up. So it's going to go up to the next 1,000, which is 17,000. For C, I have a 6. My buddy next to me is a 5. So that means I'm going to round up. So instead of 17,500, I'm going to go up to 18,000. That's why C is wrong. And the same thing with D. 7 into the thousands, and my buddy is an 8. So that's more than 5, so I'm going to round up to 18,000. All right, so that's how we got this one here. All right, hit pause and jot this down into your notes. All right, we got another geometry and a fraction problem for number 13. The answer is C. And for 14, the answer is also C. All right, let's go into 13 first. Which one is a right triangle? And as soon as I see a right triangle, I know it means that 90-degree angle has to be somewhere. And this is the only one that has a right angle because it has that perfect perpendicular, those two perpendicular lines that make a nice 90-degree corner angle. Let's go to 14. Mr. Jonas ordered pizza to take home. He ate, his children ate, 4/8 of the pizza. Mr. Jonas ate another 2/8 of the pizza. The remaining pizza was saved for later. What equation could be used to represent the whole pizza? All right, so we want to represent the entire pizza. So again, 2 ways I can think about this. One visual, one with an expression. So one, we know that kids ate 4/8. and Daddy, Mr. Jonas, ate 2 8s plus some number to get 1 whole pizza. And again, we know that 1 whole pizza just means 8 out of 8. So what number would be missing? So 4 plus 2 is 6. 6 plus another 2 would give us 8 out of 8. And that's why we have this answer, C. 2 8s plus 2 8s plus 4 8s. It doesn't matter that they're not in the same order because it's a commutative property, but I can add all of these together to get 8 out of 8. So that's one way. Another way I can kind of see some kids doing this problem is maybe they're just making some kind of either a circle or a box. And they're like, okay, let me cut it into 8 pieces. And they might already start thinking, well, the kids, this is what the kids ate, 4 out of 8. And the dad, Mr. Jonas, ate 2 out of 8. And so now we have 2 out of 8 left to make the whole pizza. So this could be a visual that could be used to find the numbers, and then we can use that to make the expression. All right, hit pause and jot this down into your notes. Let's look at 15 and 16. For 15, the answer is A. And for 16, the answer is B. So check it off and stay here if you want to see how I work through either of these problems. Allison is training for a race. She runs 8/10 of a mile every day. Which fraction is equivalent to the number of miles Allison runs in 7 days? So again, I can see 2 different ways. I can see repeated addition and I can see multiplication. So we could say 8/10 of a mile, and she does this 7 days in a row. And I can add all of those up, or you can just say 8/10 times 7. And I can just put a little 1 under it to actually multiply it. All right, if you decide to add them all together, I would just count by 8. 8, 16, 24, 32, 40, 48, 56. And you would get 56 out of 10, which is A. Or you could multiply it. 8 times 7 is 56 over 10, which again, same answer, A. And just like in the last problem, we're leaving it improper. Like honestly, there are times I cover up the answer and I would have at first done 5 and 6 over 10, and then I would have simplified it to 5 and 3/5. And then I would have, this is me being very honest and real, I would have freaked out when I didn't see this number. So sometimes that happens. So if I looked here and I'm like, I don't see this answer, I might go and look, well, do I see this answer? And I will go, no, I only see fractions. So then I will go back again and I would see this in my work. And that's why it's so important to actually show all my work and not try to do all of it in my head. Especially if I freak out, I'm going to forget the numbers I'm holding on to in my brain. So do it on paper, capture it somewhere, so that in case you did some extra work, you can still find the equivalent answer in your work. Let's go to the next one, which is a division problem. We want to do 102 divided by 6. So this is a long division problem. And here's some things we're going to tell you for long division. So if I see 1, 2, 3 numbers here inside the house, then I want to see 1, 2, 3 numbers in my quotient. Think of it like a hat on every head. So every number here gets a hat on top of it, even if it's 0. It's going to be super important because it will help stop super small problems that come up when kids divide. And if you can't remember the steps of division, you can do something saying that some of my kids used to say, dead monkeys smell bad. And that just stands for divide, multiply, subtract, bring it down. And they kept saying it, divide, multiply, subtract, bring it down. And this can help you go through all the steps. So let's start with 6. Can 1 be divided by 6? No, there's not enough to share. So I'm going to put a 0 over that 1. Again, it's a placeholder. It's just for my place value. So, and you can have 0 as one of the digits up top. So now I can think of these 2 numbers. That's 10. All right, how many 6s can I share from 10? I can get 1. So that's a divide. And now multiply. 1 times 6 is 6. Subtract. 10 minus 6 is 4. Bring it down. And I get the 2. And 42 goes into, how many 6's can go into 42? Say it again. 42 divided by 6. Or sometimes kids say how many 6's can go into 42. If you're not sure, I know some kids go and they skip count on the side to see if they can to help them. So they might skip count until they get to 42 or just not past 42. And they go 1, 2, 3, 4, 5, 6, 7. And they put a 7 up here. Now multiply. 7 times 6 is 42. And I get 0. So my quotient, my answer is 17. All right, hit pause and jot this down into your notes. All right, let's look at 17 and 18. The answers are A and D. Check them off in your work. And if you're still here, we're going to go over the first one first. You want to know which comparison is true. So in order to compare, I'm going to use a strategy of making both same denominator. It just makes it easier. If I can get the denominators the same, it's super easy for me to compare. So I'm going to put A, B, C, D so I can look at them, even though I know the first one is going to be true. And I'm going to use this property of one method, meaning I'm going to multiply by a fraction of 1 to compare. So watch what I'm going to do. I'm going to use this denominator to multiply by this side by 12 over 12. And this denominator multiply this fraction by 3 over 3. Okay, so I'm still multiplying by 1, but I'm making it into a fraction. And I'm doing that because I know that if I can do 3 times 12, I get 36. I'm going to turn both of these denominators to 36. All right, makes it much easier. So with the first fraction, 12 times 2 is 24 over 36. And the second fraction, 8 times 3 is 24 over 36. And now that they have the same denominator, I can compare them. And because my numerators are also the same, this is equal. So I love this method a lot. It's just one thing that can quickly show me whether or not my fractions are the same. Now with the next one, with B, even though I have the answer, I want you just to see this one. These two already have the same denominator. So I can tell they're not equal because 4/9 is going to be less than 8/9. Done. With C, they're using a comparison symbol. Doesn't matter. I'm still going to use the same method because I want my denominators the same. I want them to be 40. So I'm going to multiply by the opposite denominators and multiply by 1 using that opposite denominator. So on the left, I get 30 out of 40 is greater than 36 out of 40. And that's not true. 36 is more than 30. So nope, that's not true. So C, and that's wrong. And with D, again, 2/4 is greater than 2/3. Now I'm going to use a little bit of common sense here because here my numerators are the same. So because my numerators are the same, what do I know about the denominators? I know that the smaller denominator is going to be a bigger piece. Like it's like when you want to share, if you had to share something, would you rather share with 3 people or 4? I'd rather share with less people so we all get a bigger piece. So I know that this is the bigger one. So this one is not true. Now, if that didn't make sense to you, you could still use the other method and just multiply by 1. I want both denominators to be 12. So 6 and 8. All right, 6 is not greater than 8, so there you go. Not true. All right, so you have some thinking that can be used to help you compare fractions. Let's look at the next one. Oh, this is a nice multiplication one. What is the value of the expression? All kinds of different methods you can use. Traditional. I like lattice, to be fair. I kind of like lattice a lot. Haven't done lattice in a long time. I'll show both. So if you like a lattice, this is a 1 by 4. So here's 7 and 2, 8, 1, 6. And I like because I can go by it from left to right, like reading. 2 times 7 is 14. 8 times 7 is 56. 1 times 7 is 7, so 0, 7. And 6 times 7 is 42. And now I can just add all of my rows like a slide and go down. So I have 2. 4 plus 7 is 11. Carry the 1. 1 plus 6 is 7. 9. And 1. 19,712, which is D. And I know a lot of parents prefer traditional, and that's alright too. It's fine. Works the same way. And I'm still multiplying the same digits. I'm still doing 6 times 7 is 42. 7 times 1 is 7, plus 4 is 11. 8 times 7 is 56, plus 1 is 57. You just have to hold on to the numbers that are carrying over. And 2 times 7 is 14, plus 5 is 19. So both work. There you go. There's letter D. Hit pause and jot this down into your notes. Alright, let's look at 19 and 20. The answer for 19 is D. The answer for 20, lines of symmetry, is C. Jot this down into your notes. If you have it, awesome. And if not, just stay right here. No worries, I got you. With the first one, they want to know the 3 models are shown. 3 models below are each shaded to represent a different fraction. What is the sum of the fractions represented by the shaded parts? So with the first one, I have 3 shaded out of 6. And then plus 2 shaded out of 6. Plus 5 shaded out of 6. So when you add them all up, my denominator stays the same. 3 plus 2 is 5, plus 5 is 10. So I get 10, 6, which is, like I said, right over here. Now, if you had changed that, again, to sometimes I cover my answers. So a lot of times, like when I'm doing multiple choice, I cover so I can't see it. And then I just do the math first. So if that happens, then I'm in this habit of just changing things to from improper to a mixed number. So I would have said 10 divided by 6 is 1 with a remainder 4 out of 6. I mean, I would have simplified it. And that was a big thing when I taught 4th grade. We had to get it to simplest terms. That's not so much of a requirement right now. So if that would have happened, I would have, again, gone and said, all right, do I see this answer? No. Is it equivalent? Do I see it's equivalent 1 and 4, 6? No. And then I probably would notice they're all in fractional form and just would have gone back into my work. All right, let's look at the next one, which has to do with lines of symmetry. And that means I can fold it. And when I fold it, the pieces line up piece to piece, like edge to edge. And so I have to really be able to look at this and think, how can I fold this? So like if you had folded it this way, these 2 sides aren't going to fold over each other. Like they're going to lopside over. That's not going to work. But I can fold it in half this way and make 2 equal pieces. So this is symmetrical. And I could also fold it in half this way, and these 2 ends would have gone together too. So this has 1 line of symmetry, 2 lines of symmetry. That is C. So definitely couldn't have been A or B, and I don't see any other lines of symmetry that would have worked, because again, here and here would not have worked. If it was just a square, yeah, we could have folded it in half this way, but we don't have a square right now. All right, so hit pause and jot this down into your notes. Okay, we got a rounding and we have some subtraction with mixed numbers. So for 21, the answer is B. And for 22, the answer is also B. Jot it down into your notes. And let's start with the first one, 21. It says a number rounded to the nearest thousand is 4,700. Which number could be the number that was rounded? So again, remember, you're looking to the buddy to the right. So you're going to look at that buddy on this side to the right of the thousands place. You're going to look at the hundreds, and you're going to decide if it's 0 to 4, you're going to round down, and if it's more than 5, round up to the sky. All right, so here's our first number, 46,295. So here's the thousands. Here's the buddy. It's a 2. So 2, 0 to 4, round down. So this is going to go down to 46,000. Okay? And I want to make sure you guys get why that's the 46 and not 45, because that happens a lot of times. A lot of kids, they go down and they make the digit in the thousands go down another one. But when I think about this number, 46,295, it is between 46,000 and 47,000. So it is closer, in this case, to 46,000. If I went down to 45,000, look how it would be much farther away. So that does not make any sense. So it goes down to just a flat, round 46,000. All right, but that's not the number we want. We want 47,000. Let's look at the next one, 46,504. So here's my 1,000. I'm going to look at my buddy on the right, which is a 5. So I'm going to round up. If it's more than 5, round up to the sky. So instead of 46,500, it goes up to 47,000, which is the one we want. Okay, so that was it. So and I'm just going to do C and D super fast. So 47,520. The buddy is a 5, so I'm going to round up to 48,000. And for D, 47,924. My buddy is a 9, so I'm also going to round up to 48,000. That's why those two are wrong. All right, let's do some subtraction. A lot of kids get freaked out with subtracting fractions, but not me. We're just going to take it a piece at a time. First things first, I like to stack them. So I'm going to stack 4 and 1/4 minus 2 and 2/4. And I like to ask myself, do I have enough on both sides? So can I do 4 minus 2? Yep. But I can't do 1/4 minus 2/4 because I only have one piece. So we're going to borrow. We're going to take one of these. Now I have 3. And I'm going to break that into 4 more pieces, 4 out of 4. Now I have enough pieces. I have 5/4 minus 2 and 2/4. And now I have enough. 5/4 minus 2, I got 3/4. And 3 minus 2 gives me 1. All right, so that's all we have here. Now, some kids also like it with drawings, and that's fine. So some kids have, here's 1, 2, 3, 4. And then in the last one, they may have, like, let's say, how do I put this? They have 1/4 right there. And they might go, okay, can I take away 2? Yes. All right, now how am I going to take away 2/4? I have 1 here, but I don't have enough. So they can break one of these up into 4 more pieces. And now I could take away this one and this one. And then you can see why you have 1 and 3/4 left. Both ways work. Whichever works for you. I just like the standard algorithm a little bit more, but if the visual helps you, because then you can see what pieces you can break, that's awesome. You can use that. Just make sure you can recognize the fractional pieces you have. Like I think what's hard here is being able to see 1/4. Like that's a little bit hard, so you might have to like maybe like we'll color it with something so you can see it a little bit better. All right, hit pause and jot this down into your notes and make any corrections that are necessary. Let's look at 23 and 24. 23, the answer is B, and 24 is A. Check off with your work. All right, and let's look at 23. How many hundreds are in 1,000? There are so many different ways I kind of thought about this. And one was, I was kind of thinking about place value. And here I have ones, tens, hundreds, thousands. So if I only had a $1,000 bill, and I want to know how many hundreds I have. All right, I want to look to this place, the hundreds, how many hundreds of what I have. I would have this many. So 1,000 is equal to 10 hundredths. And that kind of makes sense because I know that there's like a magnitude of 10 here. Like I know that 100 is a tenth of 1,000. So that's one way I was thinking about it. The other way I was thinking about it is I was like, well, how many, if I were just to count by hundreds, how many would I need? So if I was just counting by hundreds, and when I kept on adding it in my head, 100, 200, 300, 400, and kept going, I had to do it 10 times to make it to 1,000. So I was just thinking about it in that way. And what another way some kids do is they just do, well, what is 1,000 divided by 100? And they would think, well, I can't divide 1 by 100. I can't divide 10 by 100. But 100 goes into 100 one time. Bring down to 0. And 100 goes into 0 times. So they get 10. So all these different ways I could think of for answering that question. All right. Now for 24, we want to know which of these is not true. So I would have set my paper up again to do all 4, A, B, C, D. And even if you're doing this on computer, you get scrap paper. So you can give yourself room to stay organized. And I would just see, is this true? 5 times 3/4 is equal to 15 over 20. And I want to know which one is not true. Well, if I was multiplying this, 5 times 3 is 15, but 1 times 4 is definitely not 20. I would have gotten 15 over 4. So this is not true. And if you had done the other ones, I'm only going to do this one here. 4 times 2/5, you would have gotten 8/5. And they wanted to know, is it equal? Actually, this is an equation. 4 times 2/5, is that equal to 8 times 1/5? I would have put 1 on both of them, and I would have done both of them. 4 times 2 is 8 over 5. 8 times 1 is 8 over 5, so that would have been true. And the same thing, C would have just been checking the multiplication. And you would have got 15 over 6, which is what you got. And D would have been another equation. See, I said I wasn't going to do it, and then I kind of wanted to get to D to get us used to it. So we're not freaked out by this. And I would have just multiplied. 2 times 8 is 8 over 8. 8 times 1 is 8. 1 times 8 is 8. So that is also true. And in this case, we're looking for the one that was not true, and that is A. All right, hit pause and jot this down into your notes. All right, 25 and 26. A pattern problem, the answer for 25 is C. And a geometry problem, the answer for 26 is B. Check it off in your work. We'll start with 25. What is the rule for the pattern below? So one, I see the numbers are getting smaller, so they're decreasing. And now I need to figure out what are they decreasing by consistently. So for 41, well, minus 3 gives me 38. And then 38 minus 3 gives me 35. Like, honestly, in my head, I'm doing 38 minus 35 is 3. That's really what my brain is kind of doing. And 35 minus 32 is also 3. So I'm noticing this pattern of decreasing by 3, and I can check the next one. 32 minus 3 would have given me 29, which is boom. So that's my rule. Subtract by 3. And that gives me C. Let's look at 26. Which one appears to be a rectangle? I love how they say appears, like we're measuring all the angles. And when we think of a rectangle, we have 4 right angles. That's what we're looking for. That's why we call it a rectangle. And the only one that has 4 right angles is B. And I know you're thinking, nah, miss, that's a square. Squares are rectangles because they are quadrilaterals with 2 sets of parallel lines and 4 right angles. The only thing that makes it a special rectangle is that all sides are also equal. but it's still considered in the rectangle family because it has 4 right angles. All right, hit pause and jot this down into your notes, young ones. All right, we have 3 problems here for 27, 28, and 29. 27, we have C. 28, B. 29, C. Check them off, and I'll start with 27. Which expression has the same value as 7 times 3/4? So I'm going to simplify this so I know its value, and then I'm going to simplify all of them to get its value. So 7 over 1 times 3/4 is 21 over 4. So I'm going to find which of these has that same value. So I'm going to put a little 1 for A, 21 over 1, and that will give me 3 times 21 is 63 over 4. That don't give me the same value. For B, I get 63 over 28. So 1 times 28 is 28. Nope, not the same. And this is where kind of like I wish I had made my 4 squares, because look at how my work gets really small. So 21 over 4, whoops, not over 4, over 1 times 1/4. So I need to slow myself down because I made a silly error. 21 times 1 is 21, and 1 times 4 is 4. And these two match. And the last one would have been 21 over 1 times 1 over 28, and that would have been 21 over 28, which does not match. C, place value, which expression shows 125,208 written in expanded form? So I'm just expanding this out. So 125,000, so that would have been, let me just put it here. I would just rewrite the number, and then I would just start from the biggest number. So 100,000, and then drop the 2. That's 20,000. Then go to the 5, 5,000, and go to the 2, 200, and then here's the 6. So that's what I'm looking for in expanded form. All of them have 100,000. Not all of them have 20,000. So automatically now I can knock out A. And then which ones have 5,000? We already said striking out A. I can strike out C now because I had 50,000 here. That's wrong. And now 200, I can strike out D because it has 2,000 instead of 200. So yeah, this kind of helps me to look for what I want, and I can use that strikeout. There you go. There's my answer, B. And for 29, what is the product of 3 and 2,470? So we could just do multiplication. 0 times 3 is 0. 7 times 3 is 21. 4 times 3 is 12. Plus 2 is 14. 3 times 2 is 6. Plus 1 is 7. There's my C. Alright, hit pause and jot these down into your notes. Alright, for day 1, this is the last multiple choice. We are going to do the multiple choice from day 2 as well. But we'll do this last one from day 1. The answer would be B. And they want to know the perimeter of a square is 120. So here's my square, and I know the whole perimeter around it is 120 feet. I want to know what is each side. So because this is a square, I know all sides are the same. So I have the same number added up to get to 120, or 4 times some number gives me 120. So I can just divide 120 divided by 4, and that gives me 30. And that's it. So 30 plus 30 plus 30 plus 30 gives me 120. Hit pause and jot this down into your notes. All right, on day 2, there are only 5 multiple choice. We're going to do these 5 together and end this video. Remember, every multiple choice is equal to 1 point on the scales, and we'll talk about how many points you would need to get to a level 3 or level 2 in the next video. So the first one, the answer would be D, and the second one, the answer is C. All right, with the first one, we want to know 31, how many lines of symmetry do we have? This is a regular hexagon. Which means it has 6 equal sides and angles. And that's important because it means I can turn it and it's going to have a lot of symmetry to it. So I'm going to start with the first place where I can cut it in half, which would be this way. Just right down the middle one. That's my first line of symmetry. But I could also turn the other direction from this point to this point and have another line of symmetry. And cut it in half this way and get a third line of symmetry. Cut it half this way and get a fourth line of symmetry. In half again this way, 5 lines of symmetry. And from here to here, 6 lines of symmetry. And by the time I get to this one, I've already counted that one, because I have it on the bottom. That's the same one that I started off with. So when I have 6 equal sides, 6 equal angles, I have 6 lines of symmetry. So anytime I have a regular polygon, the equal sides, the equal angles will also tell me how many lines of symmetry I will have, because it has turn symmetry. I can turn it and it'll keep being symmetrical. Let's look at 32. This one's a spicy one. A group of 80 students go to the zoo. The price for each student to ride the bus is $3. The price for each student to go to the zoo is $2. What is the total price to go to the zoo? Okay, so every student needs $3 for the bus and $2 for the zoo. And there are 80 students altogether. So there are different ways we can think about this. One is you can say, well, there are 80 students and each student altogether needs $5. So you can just do 80 times 5. And you will get 400. So I can see kids doing that. I could also see kids doing it one piece at a time and doing 80 times, not 5. They might be doing 80 times 3 to figure out the bus, and that's $240. And then 80 times 2, which is another $160, which would have been to get to the zoo, and just add them up together to get 400. That can also work. All right, hit pause and jot this down to your work and share other ways if you had other strategies for any of these problems. All right, 3 more to go, 33, 34, and 35. So 33 is D and 34 is A. So with the first one, we're doing comparisons again. So again, I'm just gonna organize my workspace and see which one is true. So is 1/3 greater than 3/4? I'm going to multiply by the opposites and use that to make 1. So great. Here I get 4 out of 12 is greater than 9 out of 12. That's not true. So I can see that for A. A is not true. Here's 4/5 is less than 1/3. So I'm going to use the opposite denominator to help me again to make like denominators. So the top one on the left, 12 over 15 is less than 5 over 15. That's not true. I can cross out B. At least these are supposed to be equal, 1/3 and 3/4. And on the left, I get 4/12 is equal to 9/12. Yeah, that's not true. So much easier when my denominators are the same. So much easier. And here's my last one. And 5 times 3 is 15 over 20 is less than 16 over 20. That's true. So again, and I'm using this, I'm always using the opposite denominator to help me figure out how to multiply and how to compare these fractions. All right, let's look at the next one. We have an incomplete area model, and I want to see which one can be used to find a product of 35 and 43. So which equation shows me? So I'm just all I'm doing is putting in the numbers in the model. That's it. That's all we're doing. So with the first one, 3 times 4, I know is 12. And 2 zeros because I have 30 times 40. 3 times 3 is 9 times 10. There you go. So that's what I kind of do in my brain. Instead of doing 30 times 3, my brain is doing 3 times 3. And then it's pushing it to the next place value with 0. So I have 0 rules in my mind. 40 times 5 is 200. And 5 times 3 is 15. So I know I'm adding these numbers. 1200 plus 200 plus 90 plus 15. Just the numbers in the boxes. And the only one that matches that is this one over here, which has the exact same numbers. 1200, 200, 90, and 15. And I should check to make sure that they have the same final answer. Wouldn't that be a thing? And I get 5, 9 plus 1 is 10. 1 plus 2 plus 2 is 5. And 1, yep, same answer. So that's A. Hit pause and jot this down into your notes. And here's the last one, 35, the very last multiple choice problem. Which expression is equivalent to 2 and 4 6? And the answer is B. Alright, so all I'm going to do is I would just do each of them one by one, and I would just add them up. So for A, I have 1 plus 1 plus 2/3 plus 2/3. And so I have 2 and 4/3. Nope, I have 2 and 4 6, so that doesn't match 2 and 4/3. So I'll go to B. 6 over 6 plus 6 over 6 plus 2 6 plus 1 6 plus 1 6. So these right here I know are 1 and 1. So automatically I now have 2 plus 2 plus 1 plus 1 is 4. So that's 2 and 4 6. That's what I wanted. So there's my answer, B. If you kept on going for C, let's give C a little bit more space. You would have had 1 plus 1 plus 3 over 3 plus 1/3. So 1 plus 1 plus 1 is 3 and 1/3. That's not what I wanted. And D, one plus 1, that's 2. And 1, 2, 3, 3, 6. And that's not what I wanted. Alright, so there you have it. That's how we got our answer B. So you'll notice that for some of these, they just want to know what's equivalent, and for some you have to do it all together. But that's it. That's the last of the multiple choice problems. Again, there were 35 problems, each worth 1 point. So right there, that's 35 points on the entire test. In the next video, we're going to go over the constructive response, which usually has, I think it's three 1-point problems, 1 3-point problem, and it's about 5 or 6 2-point problems. And we can add up all those points together to see where you would land if you had taken this same test last year in 4th grade. Well, that's it for today. I hope you found it super helpful. I hope you found these different methods helpful. And if you have different methods for different numbers, share them in the comments. And if there's some questions in here you're not sure about or you want to learn more about, please let me know, and I can suggest more videos or even make little videos on some skills or certain types of problems. That's it for today. I'll see you in the next one. Be well, Math Marvels. Bye.